This lesson is about root functions and graphs. Remember, at the beginning of the semester when we were looking at the basic graphs, one of our graphs was y equals the square root of x. When we graphed that, we saw that it looked like this, and that it had the domain 0 to infinity. If we look at the picture, we can see, if we sweep across from left to right, that we first start crossing the graph at 0, including 0, and we continue on into infinity. If we look at the function algebraically, we see that to take a square root, we have to have a positive number under the radical to have a real number result, but we can also take the square root of 0, which is 0. So that means that 0 is included in our domain. If we look at the concept that the value of x has to be greater than or equal to 0 to have a real number square root, that gives us the same information. Let's say that we look at the square root of x minus 4. Think of the transformation and draw a quick sketch of this graph and then write its domain. Pause the video and do that, and then turn the video back on. Okay, using transformations, we see that the minus 4 inside of the radical, inside of the function, gives us a transformation right 4. So our basic square root graph moves over 4 units. And then we can see from the picture that we include 4 and then go to infinity. If we think about this algebraically, we know that x minus 4 has to be greater than or equal to 0 for the whole thing under the radical to be 0 or positive. And then if we solve that inequality, we have x is greater than or equal to 4, which is the same result that we had from looking at the picture. So we can use this method to solve, to find the domain of a function with a square root. Remember here, we knew x minus 4 had to be greater than or equal to 0, solve for x. Here, x had to be greater than or equal to 0, solve for x. So on this example, we're going to set 4 minus 7x greater than or equal to 0, and then solve for x. So I want you to pause the video, solve this inequality, and then write the domain. So we see that if we solve this inequality, we have 4 minus 7x is greater than or equal to 0. We can subtract 4 from both sides. That does not change the direction of the inequality. But then at my next step, I'm going to divide by negative 7. And remember that dividing or multiplying by a negative number switches the direction of the inequality. So when I divide both sides by negative 7, my inequality reverses direction, and I have negative 4 over negative 7, so x is less than or equal to 4/7. If I write that in interval notation, I can think about it on a number line. If I have 4/7, x is all the numbers less than 4/7 over here, including 4/7. So my domain is negative infinity to 4/7. Up including 4/7. So I have a bracket. You try this one. Find the domain of f of x equals the square root of 3x plus 5. Pause the video, work the problem, and then check. So to find the domain of a square root, we set 3x plus 5 greater than or equal to 0 and solve for x. And now I'm dividing by a positive number. It does not affect the sign. So x is greater than or equal to negative 5/3. So my domain is negative 5/3 to infinity. Let's look at a function that's a cube root. Remember that the cube root looks like this. And we can see that the domain of this function is negative infinity to infinity. We can put any number we want under this radical because it's a cube root. For instance, the cube root of negative 8. That's asking me what number would I multiply by itself 3 times to get negative 8, and that would be negative 2. So the cube root of negative 8 is negative 2. That shows us that we can use negative numbers, positive numbers, and 0, take the cube root, and get a real number answer. So my domain is all real numbers. What if I were to transform this? If I were to move it left or right or up or down, I see my graph would still have domain all real numbers. And if I were to do a reflection, I still have domain all real numbers. So what that shows me is that regardless of what the cube root is, if it has stretches, reflections, shifts left or right, we don't have to do any algebra. The domain is going to be negative infinity to infinity. In our next video, we're going to look at solving equations with roots in them.